Okay, so we're talking about an Euler trail, and that means we're allowed 2 or 0 odd vertices. So let's look at our vertices. This one cuts 5, this one cuts 4, this one cuts 3, 5, 5, and 4. So often with these questions they talk about adding edges, but this one they talked about removing edges just for a bit of variety. Now if we look at this, if I look at this edge and I get rid of that, then this 5 becomes a 4, this 5 becomes a 4, and now we only have the 3 and the 5, which meets our criteria of only having 2. So that's one way of doing it, all right? So where else can we do that? So we said we could do this one, so those 2 5s become 4. Well, these 2 5s can become 4, or these 2 5s, again, it's the same pair, but different edge. Here's another edge, will make the 2 5s 4, and there's actually another one right up here at the top that makes the 3 into a 2, and the 5 into the 4, and that's 5 edges we looked at. So we could actually look at this and say, okay, the answer is E5. And again, classic problem is normally like they'll say things like, which edge, if I add an edge here, that would make that 6, and that's 6. So you can see you can add an edge or remove an edge, but it's always often like this idea of the ones that connect two odd things together. You could have done any sort of connection like these things. You could have done a similar thing like, oh, a big blue one around like that. So please have a look at these questions. This is a very good one to get right because only 29% of people got it right. It was very, very poorly answered. So it's a good one to get right because other people won't get it right, and that means your ATAR is going up. Okay, so we have a graph with 6 vertices. So there we go, that's our 6 vertices. No loops or multiple edges, which the following is not true. And the strategy here is just to draw out some of the possibilities. So if the graph is a tree, it has 5 edges. So let's go 1, 2, 3, 4, 5. There we go, lovely looking tree. We can do that. So it's true, therefore it's not A. Let's try the next one. Next one says, if the graph is complete, complete means every vertex is connected to every other vertex. So that's 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3. 1, 2, 1. If you did actually pay attention to all that, you did actually get 15. And we also know that because it's to do with triangular numbers. So this is 1. Makes a triangle, it says 3. This makes a bigger triangle at 6. This makes another bigger triangle, which is 10. And this makes another bigger triangle, which is 15. And you can see that when I did that because the first one I connected to 5 times 4 plus 3 plus 2 plus 1. That is a triangular number. It is all correct. So let me just clear all that big mess off there. And so we can say B is correct, so it is true, therefore it is not the right answer. C, if the graph has 8 edges, it may have an isolated vertex. So let's say this is the isolated vertex, it's still the one that's sitting on its own, not having any friends. We can still go, it should be, we can do 10 because it's the next triangular number down. So it's 1, 2, 3, 4, 5, 6, 7, 8, and as you can say, you can do 9, 10. So you could easily do an 8. You could do 10. Therefore, C is true because if you've got 8 edges, you can still fit in your isolated one. If it's bipartite, it'll have a minimum of 9 edges. Well, bipartite, that means that 2 parts, and this is probably where people got thrown away. So if you're not sure, put the question mark next to it. Let's look at E instead. If the graph has a cycle, it will have a minimum of 3 edges. So a cycle. There's a cycle. Interestingly enough, you can leave the other ones isolated. So you can't make a cycle smaller than that because we're not allowed multiple edges. So that one's actually true. So this one is ruled out. And let's go back to that bipartite. What do we actually mean with that bipartite? With the bipartite, you could do this. There's a bipartite graph. So everything on one side, on this side, is connected to everything on that side. So you've got all these pairings, the bipartite, two parts. So the answer for this one is D. And again, this was done very, very poorly. So it is very good to know all your terminology. And also, could you see the strategy of the bipartite graph? This question was the worst answered one. Only 26% of people got it right. In fact, more people got it wrong. More people chose B if the graph is complete, it has 15 edges. Well, that's terrible, isn't it? You didn't know your triangular numbers when you could have just drawn the 6 things and squiggled all over it. I think that's actually the real strategy, and that's what the VCAA recommended. Okay, so we've got a flow problem. So we know maximum flow equals the minimum cut. And there's always two things to watch out for here. Is it a cut? And backflow. I can guarantee there's going to be some backflow in here somewhere. Let's just check. Is everything a cut? If we look, cut A does cut off the source from the sink, so cut A is. B seems to cut it off completely. C does as well, D and E. So that's not a problem for us. So there's no funny ones where the cut isn't happening, but we've got this backflow. I'm sure we're going to spot some backflow. So if you go through this whole problem and never find any backflow, then something's going wrong, isn't it? So let's have a look at, first of all, cut A, which is this one. And let's add them up. So we've got 11, so equals 11 plus this X plus 10 plus the 4. So that means A is X plus 25. Now, let's do B. We'll do it in a different color. So B, I think I spotted some backflow already. Did you spot that? So we got 7 plus 2, not plus 6. This is going that way. There's our backflow. There's X. There's our 10 again. And there's our plus 4. So if we add all that up, that's 9, 19, 23. So it's X plus 23. Well, since A and B are connected in that way, A is always going to be, whatever X is, it's going to be bigger than B. So I'm pretty certain it's got nothing to do with A. Then we can rule out A. Let's do another color. Let's do cut C. So C equals, we've got 7. It's a bit annoying, it's very close to that line there. Plus 2 plus X plus 8 plus 3 plus 4. No backflows there I could spot, so that's 9 plus 8 is 17 plus 3 is 20 plus 4 equals X plus 24. Again, that means C is always going to be more than B, no matter what you do with X. So we can actually rule out this one, so it can't be cut C. Let's look at another one. What color should we do this time? Let's go purple. All right, we got cut D. Now cut D is interesting because we've got 5 plus 3 plus 5 plus 9, but the X doesn't count. The X is going the wrong way. Plus 10. So 5 plus 3 plus 5, so that's 29, and so that's a total of 32, and that doesn't change because that's the nature of the beast. There's no x in there. So if x equals 3, b would still be only 26. So it can't be cut D. Let's do some orange for the cut E. Let's do cut E. So E equals, we got 5 plus 3 plus 9 plus 10. So 8, 17, 27. So if x equals 3, again, b would still be 26, which is less than 27. So it can't be E. So cut B if x equals 2. If x equals 2, you get 25. That's lower than any of the other numbers. So the answer is in fact B.